All right, everybody. How are you guys? It's good to be back. One live stream more. And today, oh boy, get your beverage of preference because we're gonna stay here forever. We have a lot to talk about, and but that just after the intro. Oh, start again. I'm sorry, guys. Hope so. Everybody, thanks for joining us. I'm very excited today. Let me just bring in. We don't have time to waste today. I want to bring my one of my favorite guests. One of the. Where are you, Kara?
I'm
Hello,
here.
Kara.
Hi,
We are
everyone.
live, and I can see that everybody is already in the chat. So I believe everything is working well, and we can start because today, Kara, we have a lot to talk about, right?
We do.
we
I have a,
we
a
ha-
lot to tell you.
we have a lot to talk about. There is one article about the wire foundation, this potential side effect that Karen figured it out, and we're gonna discuss about, and something that you guys are asking me forever, some updates about Varroa mite UBO assay from Kara, and she also gonna talk about that tonight with us. So without further ado, Kara, do you have something for us?
I do. I sure do. Can you see on my screen the presentation?
Yes, I think, guys, please let me know in the chat if everything is okay so we can. People are saying Kara is blurry. I don't know if I don't think I can help this from here. But
I'm blurry. Well, hopefully you can focus on the slides.
yeah, I don't think the
Maybe my
slide,
lighting.
yeah, the slide is not blurry, at least from
And,
my side.
oh, it's not blurry for you. Okay, good.
No, but yeah, I'm excited about this conversation. Oh boy.
Me too. Well, shall we get started?
Yes, let's get this rolling.
Okay. All right. Feel free to interrupt me if you want to, but I'll just take off.
Yes.
So I really appreciate first you having me. It's great to be back here on Inside the Hive TV. A pleasure to be here. Umberto asked me to come today and talk a little bit about my Meadow Foundation wire study, but also give you an update on the UBO project. So I want to do both of those. I figure we'll start with the Meadow Wire Foundation and then we can stop after that, maybe have a little chat, and then we can continue on. Does that sound okay?
Sounds perfect to me. And you guys
All
get
right.
ready, get your beverage of preference because we're gonna stay here for a while tonight. And I'm ready.
I'm free all night. All right. So really, actually, both of these projects that I'm going to talk to you about tonight really started with this one question. This was the beginning of my PhD project. You know, what I wanted to ask was, does honeybee brood contribute to hygienic behavior? And so I organized this really interesting experiment where I took queens from different genetic lines. So I had VSH queens out of then it was out of USDA. I had Minnesota hygienic breeders, and I had unselected Italians. And I took queens and caged them onto a single frame so that they could lay eggs on both sides of the frame, about 24 hours of laying. I took the queens off, took the cages off, and then what I did was I cut those frames into thirds, and then I regrafted the frames back together. And so what I ended up with was a single frame that had three different types of eggs on it, right? And so I could then put those frames into new colonies, and then when the brood was the right age, so just within 16 hours of cell capping, I introduced mites, I had control cells. You know, I would cover the frame with those old school clear transparencies, thumbtacked on, so I could keep track of each cell. And then I would monitor these cells for hygienic uncapping and removal over a period of about 8 days. What I found was really cool, and that was that the more hygienic that brood's colony of origin, so wherever that egg or that brood came from originally, the more likely those mite-infested brood cells were to be removed, regardless of where I put the frame. So regardless of the host colony. So that was really exciting. That showed me for the first time really that there probably are brood chemicals involved in hygienic behavior. And so that took me down this whole path that I've come down since, what was that, 2011, something like that. But in the beginning of that experiment, I told you I was cutting those frames into thirds. And so my advisor always had us using plastic foundation because we're pretty rough, to be honest. We're researchers. We're pretty rough with our bees. We do a lot of manipulation, not like a standard beekeeper. And so it's just a little bit more secure, less flimsy than a wax foundation. And so I was cutting these into thirds. I was really struggling to cut through the plastic. At some point, I even tried heating the wire, and I was trying to cut through the wire, the plastic with this hot wire. And just breathing fumes, really bad stuff. And somebody told me about these wax foundation frames, and I was new to beekeeping. I didn't even know this was a thing. I was like, this is great. Now I can just saw through this little bit of wood, really easily graft these frames back together for that cross fostering experiment. So I did that. I got those. I used them for the experiment. And right away, I noticed something really strange was happening in my colonies. I could see these just complete lines of missing brood. And it wasn't that the queen wasn't laying there. I could see young brood until a certain point, and then it all goes away. So, we know that honeybees and brood are really highly susceptible to stress during development. So there have been all these past studies that show brood is susceptible to pesticides, they're susceptible to poor nutrition, and they're susceptible to trace metals. Well, that makes sense because from that stage of egg to larvae, you see this incredibly high rate of metabolism, high rate of growth. So they gain within a 6-day period over 1,000 times their weight. And I read that during certain periods of that growth phase, they can actually double their weight every 3 hours. So just incredibly high growth, high metabolism. So it makes sense that there could be some stressors here going on when brood is going through these huge changes. So I said, okay, well, what are the effects of foundation wire on honeybee brood? I just have to look it up. To account for it in my project to figure out what's going on. So like a good PhD student does, I went to the literature, and actually the only paper that I could find that mentioned anything about wire effects was this one that showed that actually honey along the wire contains about 4 times more iron than honey that was collected from cells beside the wire but not running along it. So I thought that was really interesting. No one seemed to have documented this before. The wire that I used for this project was advertised as stainless steel. I say advertised as because I didn't test that, but it was sold to me as stainless steel wire. And so what I decided to do, since I couldn't find any documentation of this effect anywhere else, is I took little pieces of wire, and I analyzed them for 10 elements that are known to leach from steel. So I looked at arsenic, cadmium, chromium, cobalt, copper, iron, lead, manganese, vanadium, and zinc. Okay, so I just sent these wire samples off, had them look for these 10 different elements. The next thing I did was I looked at the effect of the wires on the chemical content of the brood. So I looked basically for these same 10 elements in the brood. And then I quantified the effects of the wires on removal of brood. So with the wire analysis, we found that the wires contained at least trace amounts of all of these elements except for cadmium. So 9 out of the 10. And if you look here on the y-axis, this is actually a log scale. So we found that the wires contained primarily iron. So here, this tall bar is iron. And it doesn't look like that much more, but this is a log scale. So it was like 170 times more iron than any other element tested. Next, we wanted to look, the important stuff, look at the brood. So we collected larvae from along the wire. So here I have this little gray line is representing my wire. And we collected brood from the cell adjacent to the wire. So right next door, but not at all overlapping the wire. And what we found, there was only one of those 10 elements that was different between the control and the wire samples, and it was iron. So the brood that was collected from along that wire contained about 3 times more iron than control brood. And so that was pretty consistent with the honey study. That it found 4 times more iron in the honey. We found 3 times more iron in the control brood, in the wire brood, than in the control brood. And then finally, we wanted to look at brood removal. So really, we're just trying to quantify what's the effect. I counted the eggs and young larvae along and adjacent to wire. Stuck the frames back into the colony for a week and pulled them back out right around the time of capping. And then we counted the larvae right there. And we found that the wire that was associated with the brood that was along the wires was 6.5 times more likely to be removed than brood that was not along those wires. But what we noticed is, when we were counting, we were really just assuming that the wire was kind of lined up directly down the center of those cells. And so we counted, one cell here and then directly under it the cell, directly under it the cell. But what we noticed is, in actuality, a lot of times the wire was not lined up exactly in the center of a cell, not too surprising. And so when that happened, we would actually see kind of this zigzag pattern of an effect. And so here you can actually see a little bit of the discoloration that we saw in the larvae. And I don't know if that's caused by the iron itself or actually some kind of necrosis or damage to the brood. But you can see here, let's see, on the left, this wire, you see it's aligned here in the center. But for most of the cases here, we have kind of this zigzag pattern of missing brood. And so, when we looked at how many cells we had on average on each side of a deep frame, it was like 3,350, with a little bit of honey or pollen on the outside. And so what that meant was that between about 200 and 300 cells, or 6 to 12% of our brood, was overlapping that wire to some degree. And so, I think this is a really important study. One, because of course you have this reduced brood survival. So if 6 to 12% of your brood is exposed, this could have a big impact on the amount of brood that's laid but doesn't actually come to adulthood. But I think it's more than that, because you have to think about the wasted resources. So for one, there's a lot of food that goes into rearing these brood. With that crazy growth rate that they have, there's a lot going on, a lot of food coming in to feed them. But also think about the time and the energy that's required for then taking all that brood back out. It's just a lot of wasted food, a lot of wasted time. I think it's also important to consider the potential for removal exposure. So you could have these workers that are removing the brood, in a lot of cases cannibalizing that brood, could become exposed to that iron that we know is in the brood, and this could be pretty devastating. So there was a study that came out in 2013 that showed that there are these iron-containing nanoparticles that are essentially lining the abdomen of the honeybee, and they're believed to be involved and essential to navigation. And so if you have all these workers that are getting exposed to iron before they become foragers and then going out to forage, we just have no idea what kind of effect that could have on navigational ability. So this was, like I said, an early study. We really have a lot of follow-up questions that have not been answered, that I think would be really interesting to look into. As you'll see in a minute when I go to the UBOs, I've been busy on a different path, but I have a lot of questions still. So, I would love to know how common this effect is. So I talk about this effect to a lot of beekeepers at a lot of beekeeping associations. And I always ask, at least when I'm in person, raise your hand if you've seen this in your colony. And I typically always get at least a handful of people who have seen it. So far, I've had beekeepers in Europe, Canada, and the U.S. tell me that they've seen it. So I know it's a pretty global thing. But I also know that there are a lot of beekeepers who haven't. So, I think it's important to know how important it is, how common it is, and where this effect is found. I also think it's really important to compare different wire types. So I know some people use no metal wires. There's different types of metal wires. Of course, you can use something like fishing wire and not have any metal type effect. But there certainly are different wires that are used in different products. So to compare the different wire types, I think would be important. I think it also, one big question I have is does this effect last? So, this was a brand new study. I had just bought those frames. They were all freshly drawn out. But if you go through 2, 3, 4, 10 brood cycles, do you still see that same effect? My guess would be that it dissipates over time, but how quickly, we just don't know. So that's another question I would like to see answered. We don't know also if there are effects on worker health and navigational abilities. So that's something we kind of can hypothesize from the data that shows there's iron and it's important to navigation, and they're getting clearly exposed to iron. But I think it's important to really establish whether it does have negative effects on the workers as well. And then, I never think of honeybees as individuals. Always I have to have the colony mindset. So I think it's really important to look at colony level effects. So, really, is this important for overwintering survival? Is it affecting population size? Those type of questions I think are important to answer, because we need to know how important this effect is in terms of honeybee health. Ultimately, that's our goal, is to keep our honeybees healthy. So that's what I have on the wire, short and sweet.
All right, so let's stop for a moment. Kaira, I want you back here. Well, let's discuss this first before, otherwise, I think it's going to be messy if you continue and get questions later on. It's going to be a little confusing. Let's get things fresh right now.
Okay.
And let me put you right here. So, I have questions from my patrons. Let me first tell you what's going on in my patronage, because I think people start to get interested in this more, and I want to invite people at home too. You and I are researchers, so I don't know if people at home know that we received blindly some manuscripts to revise, and I received those for scientific journals as well, and I dissect them, I smash them, I try to find all kind of mistakes on those, and I start to do this live on Patreon. So people, not the real ones, but the ones that I'm studying for my videos.
Mm-hmm.
So I start to do that to show how is the review process is done, and people start to get interested. So I want to invite everybody at home, if you want to see those live, me dissecting and trying to find all kind of mistakes in the science behind it. So that's the place to go. I want to invite you guys to go to patreon.com, and I'll invite you guys to this Patreon only live streams. So, and
That
because
sounds like
of
a good
that,
time.
oh yeah, I have a lot of fun. It's a lot of fun, and I got a lot of questions from my patrons too. So I want to ask you. I'm going to start with that because I know you mentioned a lot of potential problems, but there is one that you didn't cover so far that I think might contribute as well. the wire as messing up with the heat or the cold, with the homeostasis of the hive, depending what kind of hive you have and where this wire are connected. That wire right there could be taking heat away, or if it's too hot outside, making hotter. That might be another thing, and I would like your thoughts on that. Do you think that's possible?
Yeah, absolutely. I think it's possible. I haven't tested it myself, so I can't say.
Yeah,
But yeah, I think it's certainly possible, especially if you have some connection. Metal really conducts heat well. So that's
yeah,
why I learned early on you don't want to leave that metal clean excluder in. Bad news.
nope, yeah,
Just getting all that cold to the center of the colony. Yeah, so I think it could have a similar effect. Especially if you have some contact of the wire with the outside, which I'm not sure you would in most cases.
yeah.
But
I can tell you myself, I had this problem when I was a kid doing the things for my dad in the past. And I remember very well because my dad got mad at me when he see those brood patterns, because he said it was my fault that I didn't put the wire correctly in the right
mm,
spot. So I remember correctly
I did not
very
realize
well.
this was personal.
What was personal to me when I saw that, I called dad. I said, "See, it's not me."
It wasn't me. Yeah, so I should add in Brazil to the list of where it's been seen.
Yes, because they use a lot of this kind of foundations there. I think the
Yeah.
great majority of beekeepers use that.
Yeah, and I don't know, how frequently it's used now. That'd be another great question to answer. I know when when I did this research, it was the number one selling product from this bee supply company. Um, so I know that it was very popular then. I don't know now if that's still the case. I know a lot of people do foundationless or have switched to coated plastic. But it's another question is how widespread is use of these foundations, anyways. But if you do use it, I would just recommend that you keep an eye out for this. If you don't see it, then maybe it's not a problem.
Yeah.
But if you see that removal,
But what is good to see that you did the account. So it's 10 to 12% less brood, basically.
right?
And
Yeah, and
plus all the resources that is involved to grow that brood and to take care of that, right? Wow.
that's right. And you're gonna offset your brood pattern, because so maybe the queen comes back and lays again in there, and they develop a whole new generation, or part until they remove it again. But it's kind of off sync with the all the capped brood around it, and so I think it can just become a myth. Or maybe they fill it with honey. Who knows?
Yeah, I want to know from people at home if you have this experience. So let's start to get some questions from people at home. So let me see here. Oh, hi everybody. Wow, so many highs. You guys are amazing. So let's see if there is any questions here. Blah blah blah. Trees,
I
mountain, blah.
I would love for people to type in if they've seen it,
Yes, that would be great if you guys can, if you have seen this before.
and where you are.
Yeah.
Where has this been seen before? That'd be great.
Oh, wait a second. Let me see. Let me try to put some of those comments here. Oh, hello, hello. A lot of hellos. Let me. I'm gonna get there. Let me see. There is this comment. We're gonna put it here so we can until I find more things.
The fishing wire. Oh, yeah, that's a good question. So this Flower Street Farm Bee says, I've used fishing wire in foundationless frames, but have wondered if there's a leaching effect. I try to pull out the wire after comb is well attached to inside of sidebars. I have not heard of a leaching effect from fishing wire. I've actually heard people say they've used it and not seen this effect, but maybe it's very uncommon to use it. I don't know. Um,
Yeah,
I don't. What are those made of? Nylon? Nylon
I
fishing wire,
think they're
probably.
nylon. Yeah, some.
Yeah.
Yeah, I'm not a
Yeah, I'm sure
fishing
it
guy.
depends. Just like the wires, there's probably 100 different types of fishing wire,
Yeah.
fishing lines. So Always
Okay.
depends. I work with stainless wire for splicing cable. Wonder if this would be any good. So this was supposedly stainless steel wire. That's how it was sold. You know, we did test for the compounds that should be there if it's steel, and they were there. But I don't know. I don't know for sure if it was stainless as it was advertised. I assume they were truthful and that it was stainless steel.
Brad said that he has seen
Mm.
that for.
So Brad says, I've seen this for years with the
Yeah.
use of metal wires, yet with true stainless steel wire, I don't see it. Interesting.
Okay. Well, I know this guy. Hey, Mike, I need to talk to you. I'm gonna call you. It's about Apimondia. We're gonna make it. We're gonna make it.
Michael
And
Palmer says it
Mike Palmer
doesn't
is
last.
saying it doesn't last. The fact. So
So Michael, how long does it last? Do you know? That's the question.
yeah. If let us know if you know how long it lasts in your experience.
Yeah, that'd be great. And does it I guess does it throw off the whole cycle, or do they eventually start laying nice brood pattern again? That would be
Yeah.
my next question.
Well, if that's true, the whole hypothesis of heat goes away, right?
If it does, you mean if
Yeah,
it
depend
doesn't
of
last?
the time of the year, right? So yeah.
Mm.
Roger Mayers, I only see from 2 to 3 brood cycles. See, it's kind of
Yeah, that's good. Unless you're replacing your frames every year or two. I
yeah.
think that's good news.
Another comment here, Karen.
No blink. So that's actually consistent with the last viewer.
Yep.
Um, they saw it 2 to 3 rounds, maybe.
All right.
Good.
So Jack didn't see it.
Yeah, it's a good idea taking a poll. Maybe we get like a little citizen science going on. Who's seen
Yeah,
it?
yeah, yeah.
What type of wire do you use? And
I do like that very much. This citizen science, and I have one coming. I'm holding. I can't say it, but it's coming. It's gonna
I
be.
would say I would still not want to lose 12% of my brood even
Yeah.
for the first 3 brood cycles. Um, but if it does go away, that's excellent. Oh, somebody's seen it using fishing line.
Uh-oh.
Interesting. So what type, I wonder, what type of fishing line?
Yeah.
And did it go away? It says fishing line on new cone. Yeah, that's a good point. So Adam says that old timers used to say the queen wouldn't lay in them, and that's true. I actually read about it in the. I have a Langstroth text, and Langstroth said somewhere in that book that the queen would refuse to lay on it. But I know, for my queens, that's not true, because I could see the eggs and the larvae. They were just removed, pretty quickly within a week or so.
Okay. Brad is giving his location. He's New York.
Stainless steel. So it looks like we need to retest with stainless steel versus other types of wires, and then just monitor over the course of the summer and see how long does it last. Do we see it at all with stainless steel? Maybe verify that it is stainless steel, and then do we see it with other types of wire? I have not seen studies on the effects of the plastic. The plastic on, I'm guessing you're meaning leaching into the brood. I think that would be pretty limited with the wax coated plastic frames, at least. I would hope so.
Mike is back. He probably saw a lot. 40 years of wire foundation. Couple rounds, goes away. I don't know why I trust this guy. I heard a couple things about him.
Yeah, I've heard of this guy too.
Miss you, my friend. Okay.
Yeah, I haven't seen them avoid those cells. I think they lay in them again. Um, what I didn't pay attention to was, are they laying in them? Are they coming? And it might vary by space limitation, but are they coming back and laying once they're empty, or are they waiting and laying on everything on that frame again?
Cynthia from Georgia again.
I have not seen issues with wax-coated plastic frames in terms of removal. But I mean, it would just be everywhere, right?
Yeah.
So I don't even know how you would notice the effect. Even removing foundation around the wires. Interesting. They leave blank spots around the wire and fishing string. So it sounds like in New Jersey they're seeing it where the queens don't come back and lay.
Yeah.
I would think that after a couple brood cycles, it's just building up, layers inside the cell, and then you don't have the direct contact. So it's also possible maybe that it's leaching into the wax some, and still there's some effect into the brood. So that may be interesting. So if you get to the third brood cycle, say, and you don't see the removal effect, do you still see additional iron in those brood, but maybe it's not sufficient to trigger the removal? Or is the exposure completely gone?
Okay. Physiological response. So,
Behind the melanization of the larvae can be caused by hygienic behavior. So I mean, I think
yeah.
the picture that I showed with the darkened larvae was before any hygienic behavior had begun.
Yeah.
So I don't think it was caused by hygiene. Again,
It's how to link the excess of iron, perhaps that's the hypothesis, is how that's triggering the, and assuming it's melanization too, there is other things, other pathways in the immune system of honeybees that make them black. It's not only
mhm,
um I think the answer is I don't know.
yeah.
Yep.
Yeah, and it could just be the iron leaching in directly to the brood. I don't know.
Yeah. Oh, interesting. That's for you, Kara.
A little iron or a lot of plastic, which is the worst?
Yep.
Good question. I like foundationless checkerboards. Then you have at least some reduction in your uh, leaching potential. Yeah. Yeah, I mean, I think the answer to that question comes back to the follow up that needs to be done. How long does it last? Is it really gone after 3 cycles? Uh, Even if they're not being removed, are those brood that are along the wires, are they still taking in excess iron, which is affecting their navigational abilities when they become foragers down the line? So there's potentially, even if you don't see the removal effect, there's still potential there for future problems, if that iron is indeed leaching still into the brood body.
Jamaica.
Never seen the effect for fishing wire. Oh, interesting. So yeah, it'd be great if you can put which type of fishing wire you use, if you know. Because there was another comment that someone had seen an effect of the fishing wire, which is interesting. I didn't expect that.
Induced voltage on the
I
wire.
have not measured any voltage.
Yeah.
No. Curious your thoughts on that though. What are they meaning?
I don't know.
So maybe it's the quality of the stainless steel, not just the stainless or not.
Not sure what those things mean, but I'm putting here in case people at home can maybe even help us to understand. Like trilene fishing line. Mm,
Use a starter strip. Interesting. Yeah, so it might have been the stainless steel quality then.
wow, 30 to 40 types. I didn't know that.
I did not either.
Interesting question.
It is an interesting question. I didn't measure that, so I just did this in the summer. I think it was over 2 seasons, but both times in the same part of the season. So 2 years in a row, but the same part of the season. So that's an interesting question, though. Yeah, I do see a seasonal effect on hygienic behavior in general in my colonies. So I tend to see a nectar flow effect, or I don't see as much hygiene in the end of the summer and into the fall. But these were, I should point out that these colonies that I tested this wire effect on were non-hygienic colonies. These are just standard Italian unselected colonies. So, it's not like they were super hygienic and that's why they were removing them.
Do you know any effect of plastic?
I don't.
I don't either.
No,
I
I
never
don't know
heard.
that it's been looked at.
I don't know if there is a study. I never heard a study trying to measure anything like a half plastic, like have the same frame with half plastic and half something else and see what happens.
Yeah, that'd be interesting.
Thinking about this kind of project, I want to ask you
Mm.
something because, well, I think everybody at home now know that Project APIS M is and we're collaborating on this. Is a very nice collaboration. I want to ask you, Kara, you know, I know this project came from Project APIS M. Do you know any other place on the planet you can get money for research for this kind of project?
No, I mean, Project APSM has been incredible supporter of my work over the years.
Yeah.
I think it's like 7 projects or something of mine that they've funded over the years. I mean, they've just, they've been incredible. They've been there for me personally. They've been there on funding gaps that were pretty critical to like continuation of my career, or
Yeah, I want to let everybody knows about Project APSM, and if they can to show them some love, write to them, consider a donation because they really help us to. Sometimes we have great ideas, but the big funding agencies don't see the same way, and we need to show some result, preliminary result, and then Project APSM give it that little seed that allow us to change things and go to
well,
these funding agencies with much more uh, data to show and ask for more money. It's very important what they do.
it is, and I would say also they're so focused on applied research, so
Yep.
something that actually really has an impact on the beekeeper, not just like the broad questions, but really these things that they think may lead to a solution that improves honeybee health.
Yeah.
So that's another reason I
So Project
really respect
APSM,
I really respect
thumbs up,
Project APSM.
thumbs up.
2 thumbs up, yeah.
Yes. Okay, I'm completely lost here with the things already. Guys, I don't know where I am, so if I jump
So
people, you
I like this question. Is the wire wicking the heat out of the cells? That's interesting. Um,
yeah.
I was thinking before we were thinking of the environmental conditions coming in through the wire, but
Yeah,
it's also a possibility if you have honey on the outside and the wire's transmitting the heat out. Maybe the brood has to work harder to stay warm, or the bees have to work harder to keep the brood warm.
yeah.
Never seen bad brood inside. Oh, interesting. A vibration there. It could be for the fishing line. For the wire, I feel pretty confident it was related to the iron.
Yeah. Yeah,
Um,
it's something that you measure that it's wh- what we need to completely demonstrate that maybe to feed with iron and
mhm.
see if the removal happened, just to be a definitive proof that the iron is responsible for that.
Right, that it's the causative agent. Yeah.
Yeah, just to demonstrate causation.
Under the metal clean excluders. I'm not sure I understand this question.
Think they're because the queen excluder don't touch the cells, right? I don't think it's
Yeah, it's not directly in contact with the
yeah.
with the
I,
brood.
I think if it were, maybe it's gonna be the same effect.
Hmm.
Maybe, or I'm missing some fancy queen excluders. There is so many things going on in the beekeeping industry that sometimes I don't.
Right.
Some new gadgets that I what the heck is that?
Mm,
All right,
interesting.
interesting.
Yeah, I love this kind of
Yeah,
forum, this kind of
exactly.
discussion, because
Yeah, me too.
I can learn so much from you guys and your experience. You know.
Yep. And that's exactly why I did this because, for example, look at this one. I'm already thinking to write something for Project APZ.
A good
We can,
plan.
yeah, we can do a short, experiment to see it plastic and see if
Yeah,
the
I think plastic, that's a great question. Like you
yeah
said, put some strips of plastic and non-plastic and then check. You have to see what we check for. We wouldn't check for
yeah
the same elements here, but
yeah,
um,
we're gonna be kind of blind because with the wire we have a kind of direction where to go, what to measure. The iron
mhm.
is kind of evident, but for the
Yeah,
plastic,
and
not
the
sure.
brood food is acidic, right?
Yes.
I believe I remember the brood food is acidic, so it could also have an impact, yeah, on the leaching if there's all this acidic brood food. I
Hmm.
don't know.
Yep.
I'm just thinking off the top of my head that could have an effect. I did hear someone was thinking of doing a study with the queen cups, the plastic queen cups, to see if there's
Yeah.
leaching. But I don't think it ever happened.
Another observation for you, Kara.
Interesting. Saw it more with the Italians than the Carniolans. Even with the same frame type, I guess. Maybe
Mm,
those Carniolans have thicker skin, yeah?
yeah. Okay, I think I will gonna go because of the time, guys. If I jump somebody, my apologies. Send it to me, and I will send it to Kiara, and we move to email communication. Okay, I think we need to keep moving here because this
Yeah, and
second part is. Go ahead.
well, I'll just add that that study is open source, so everybody should be able to access that study if you want to look at the details of the methods and how it was done.
Yeah.
Everyone should be able to see that.
Yeah, thank you everybody for all the questions. So let's move to this second subject. That's something that you guys at home were asking forever. So let's see what this essay and this, how I say, Optera? You're gonna teach me
Optera,
everything. Optera.
yeah, Optera. It's
All
from
right.
Hymenoptera.
Oh, I see. Okay, Kara, teach me everything about what's going on with this. What is this?
Okay, yeah, I know. I'm excited to show some project updates for the UBO work, the UBO technology. So if nothing else here on the screen, we have now a product name, UBO. We have a logo here. We have a website. So if nothing else, yeah, we've made some progress. But I know you guys aren't here for the logo. You want to see the research. So let's dive in. So I want to just start with a kind of background information, reminder of some of the things we talked about last time. So hygienic behavior, I'll play this. Let's see if we can get this video to play. Hygienic behavior is this ability of the adult bee to detect, uncap, and remove unhealthy brood from the colony. So here you see in the center of the screen, they're pulling out this unhealthy pupae and they remove it from the colony. And in performing this behavior, honeybees can improve the health of the colony as a whole. I am of the opinion that this is really one of, if not the most sustainable ways to control pests and diseases for honeybees. First of all, they're doing the work for the most part instead of you, the beekeeper. Um, Also, there's no sublethal side effects for the queen, for the drones, for the healthy brood. There's no lethal effects either for the healthy brood. And for most workers. And I say most workers, this again goes back to our talk on Inside the Hive TV, our interview in December of 2021. But we talked about this, that from this preliminary data set that we saw the hygienic performers actually have much higher virus levels than the control nurses. We don't see that translated to the colony level. So we see that hygienic colonies have low virus levels compared to control colonies. But for the most part, we don't see these sublethal effects for the workers. We don't have temperature dependence when you're talking about hygienic behavior. I do have some evidence that there's a seasonal effect. I mentioned that before, and I'll come back to it later. You don't get contamination of hive products with hygienic behavior. And I think also just in terms of evolution, it's tough for the mites to become resistant to hygienic behavior. And I think that's because the workers that perform hygiene are responding to the brood and not specifically to the mite. So there's not a lot that the mite can change that would reduce its chance of being removed hygienically. And I think if evolution was to drive in one way, it would be towards the mite doing less harm, which would be a good thing. So if the hygienic adults are reacting to the effect of the mite on the brood, then if the mite doesn't want to be detected, maybe it can become less harmful to the brood and it's less likely to be detected and removed. But what we see with hygienic behavior is that the success with Varroa specifically really depends on the selection method that you use to obtain that hygiene. So we have these pin-killed brood, freeze-killed brood type assays that seem to be pretty efficient. They're pretty easy to do, relatively quick, but they're less effective in terms of your ability to really select for Varroa resistance. And I would argue that the pin-killed brood and freeze-killed brood are really more selecting for necrophoresis or removal of dead brood, but that is a highly related task to hygienic behavior. On the other hand, we have things like VSH, selection based on suppression of mite reproduction. These are relatively effective in achieving Varroa resistance of the colony, but they're just intensely, they're very labor intensive, right? So it takes a long time to perform these selection processes. So, can we have both? That's the question. Can we find this way to select for Varroa resistance that's easy and quick, efficient and effective? So just to summarize some of the early work that this UBO project builds on, we found certain compounds that are elevated in unhealthy brood, and that means not just Varroa parasitized, but also virus-infected brood. And what we found was that those unhealthy brood odors, or UBOs, could be detected by the nurse bees, and they trigger hygienic behavior. So for me, it's really important to ask these broad questions, these fundamental science questions, but also it's important to translate them kind of PAM style, right? Project APHISM style. I want to translate them into something that's useful, not that just gets published and thrown in a drawer for somebody to maybe find a use later. But really, how can I use this new data, this new information, and turn it into something that can help beekeepers, that can improve honeybee health? And so I wanted to find out, once we made this discovery, can UBOs be used now to effectively and efficiently measure Varroa resistance? And again, this is where PAM funding came in, because I finished my PhD essentially finding these compounds, and it felt like a beginning, not an end, and so we really wanted to continue, and PAM helped us do that. So we developed this mixture of lab synthesized UBOs. So these compounds are made by a lab, but they're exactly the same as they are produced by natural brood. And yeah, this gray text here at the bottom is a very short amount of words to summarize 4 or 5 years of work, but it's true. We developed that, and I also want to point out that these UBOs, they're found on every single brood. So it wasn't that they were novel to unhealthy brood. It wasn't like they weren't there, and then when the brood was unhealthy, they showed up. But it's only the ratio of these certain unhealthy brood odors to other odors that are there, to other compounds that are there. So it's just a very small change in the relative amount of these compounds. And so what we did is we took those lab synthesized compounds and we developed what we call the unhealthy brood odor, or the UBO assay. So the way this works, you take the UBO spray, you apply it to a small area of capped brood in the test area. You return the frame to the colony for 2 hours, pull it back out, and then what you want to do is look at the amount of uncapped brood that's there. Sometimes you get a couple removed, but for the most part, it's just uncapped brood. So you can really just count the number of capped cells at the time 0, when you do the treatment, and then at time 2 you recount, and then you can just calculate a score for your colony. So that's how the test works, but I think the really important thing is what happens next. So the idea isn't just that you go and test your colonies, but then as beekeepers you can then make informed decisions about your breeding or your management of your apiary based on these results. So I want to show kind of a real life scenario, what that looks like. On the left, I'll show a high UBO response. On the right, a low UBO response. Time 0, you apply the spray. And then time 2, you can see something like this in your colony. So a hygienic colony on the left. This one you can see, I think here, there's still 2 capped cells. This colony scored a 96%. And on the right, this colony scored 24%. So not much action going on here. And so you would treat these colonies differently, right? So if you get this information, on the one hand, if you have a high scoring colony, you may want to limit treatment. So maybe you don't need to use a Varroa treatment. I would certainly keep an eye on your mite loads, no matter what. I think even a colony that's super hygienic, if it's subjected to a lot of mite drift, can be overcome. Never a bad idea to keep an eye on your mites. But you might be able to limit your treatment. You might not have to treat this colony. I certainly would graft from it, and you could sell it as a breeder queen. On the other hand, on this 24%, unless you have like a really high groomer or something, some other mechanism of Varroa control here, I would certainly expect to treat this colony. If you want it to survive, you're going to need some Varroa treatment. I would potentially replace the queen. If you're working on a breeding program, and you have access to a potentially higher, take an egg from this colony on the left, right? And replace that queen. And another thing that I'm starting to think more about is the potential benefits of isolating colonies. So, if you have 2 apiaries and you can isolate your susceptible and your resistant colonies and kind of limit that potential for drift, I think there's a lot of potential to reduce drift into your resistant colonies and really keep them healthy. And so I kind of wanted to summarize for you guys essentially what we know about UBO so far. So we have first some data that's, I think, pretty concrete that I feel pretty confident in. So one of these we discussed last time. We see that the high UBO colonies are really associated with a lower Varroa infestation. So we use a 60% threshold. So we consider a colony to be high UBO if they score 60% or above on that UBO assay. And what we found in a 3-year study over 5 different sites is the average Varroa load of those high UBO colonies was significantly lower than the Varroa load of low UBO colonies. These were for untreated colonies. And what I thought was really exciting is that the UBO assay really did a pretty good job of separating colonies that fell above and below that treatment threshold. So this was all this data comes from a single UBO test in each colony in June, and these are the August mite loads. So it's a good predictor of what your mite population may look like, at the end of the season. And it really helps us separate those colonies that can handle their Varroa and those that can't. And the other thing we found was that these high UBO colonies are associated with higher overwintering survival. So survival of the high colonies was 41% greater than that of the low colonies. So a pretty big difference. Again, that's without any Varroa treatment, and a lot of Varroa in our yard. So it looks like UBO, we can achieve potentially that efficient and effective balance that we're looking for using UBO. So if that's the case, then, why doesn't everybody have hygienic bees? And this is one thing I've been asking myself for a while. And so about a year and a half ago, I stopped asking myself and I started asking beekeepers. And so I've kind of listed here the top reasons I heard of why beekeepers don't have hygienic bees. One of the main things is they don't know about hygienic bees, or they don't have good access to hygienic queens. So, maybe they've heard of them, but they don't know where to get them. Another was the cost of high performing queens. So, the queens that are really Varroa resistant, highly hygienic, that selection is really labor intensive. It can take hours and hours to evaluate each colony. And so, of course, those queens are going to be really expensive. But if you are willing to shell out the money for one of these queens, the concern then is, well, what happens if I lose my queen, or as she ages, do I just lose that investment that I've made in my apiary? And so one of the things I wanted to look at this past summer was how heritable hygienic behavior is. And I wanted to share with you some of that data and what we did with that study. So what I did was I set up a high hygienic apiary. The average UBO score for this apiary was 85%. 8 kilometers away, that's about 5 miles away, we set up a low hygiene apiary, so the average UBO score there was 29%, so a big difference. We didn't have any high colonies in the low apiary, no low colonies in the high apiary. And then what I did was I made splits from several colonies at each location. I made 2 splits. So I had these sister daughter queens. And then I moved one nuke from each pair to the other yard for mating. And so what we ended up with was essentially 4 different types of daughter queen. We had a daughter queen that came from the low hygienic mother. So the egg was from a low hygienic mother. And she mated when the daughter queen matured, she mated in the low hygiene apiary. We had queens that came from the low hygiene mother that mated in the high hygiene apiary. Queens that came from the high hygiene mother mated in the low mating apiary, and the high group. High mother's hygiene, high mating apiary. And so we then let those queens mature, and we tested them with UBO at week 6, week 7, and older than week 10 after queen emergence. And so I show you, I've removed the numbers here because this data hasn't been published yet, but I show you here the basic trend of what we found. And so here on the right, we have this 2 sets of daughter queens that came from the high hygiene mother. And here on the left, we have the 2 sets of daughter queens that came from the low hygiene mother. And so what you can see is it looks like, mom has a big impact on the hygiene level of the daughter queens, but it also seems that the mating yard has an effect. So in both kind of sets of maternal origin, those that mated in a high hygiene apiary ended up scoring higher than those that were mated in the low hygiene apiary. Another reason I hear why some beekeepers don't have hygienic bees is that they have either experienced themselves or they've heard about poor performing hygienic queens. So maybe they were interested, but they had a friend that had a hygienic queen. It didn't do what it was supposed to do, and just wasn't worth the investment. And so looking back at this graph, I just want to point out, look at the variation we get here. The lowest score we saw in this high group was below 40%. So, not a high UBO daughter. And so I just want to make the case that you can try to control everything to the best of your ability, but in an open natural mating system, there's no way to control what's going on in those congregation areas. You just can't control what drones are around, what drones your neighbors have. And so, I think that's probably why you see some of these queens being sold as hygienic that turn out not so hygienic. So what did we learn from this study? I only showed the 7-week data. We saw really the same trend, the same upward trend for those 4 categories in each of the 3 tests, so really consistent. But the 6-week test was just really high variability. Those error bars, confidence intervals were pretty large. So I would say we definitely want to wait at least 7 weeks post-emergence, 6 weeks laying minimum before you test your new queens for their hygienic abilities. It did seem that the mother's UBO score was most important. I think that's good news because it's a lot easier to choose where your eggs come from than to choose who your queens meet with, unless you have the time and skills to do AI. I do think it also showed though that the drones matter, and so if you're going to get into selection for hygienic behavior, make sure you're saturating with your hygienic drones, but also that you convince your neighbors to go for hygienic selection as well. And I think the last point with that below 40% score, regardless of where your eggs come from, who they mate with, you have to test the daughter queen. If you really want to be able to say, I'm selling hygienic queens, I think it's important to test the daughter queens, especially if you're working with an open mating system. So here, going back to our kind of summary, we see that there are these high UBO colonies are associated with higher F1 queens. All right, the next one I'm excited to talk about. I did this study a few years ago, and I haven't had a chance to write it up, but it's so fun. I love talking about it, and I've only told a few people about these results. I'm excited to share it today. So I did this really fun. I did this really. I don't know if you remember this, Umberto, from when you were in the lab, but this was a really fun experiment with essentially classical Pavlovian conditioning. Using something called the proboscis extension reflex. And what that is when honeybee antennas come in contact with a sugar sucrose solution with high enough concentration, they involuntarily stick out their proboscis or their tongue. And so what we did was we had trained these bees to associate UBOs with a sucrose reward. So the way I did that, I had a poor little nurse bee taped inside a drinking straw. And I had made these glass capillaries. So excuse my poor cartoon drawing, but I had these glass capillaries that I treated with just a little bit of UBO at the tip. And what I would do is touch those, direct contact of those UBO treated capillaries onto the antenna. And then as soon as I removed that glass capillary, I touch the antenna with sucrose solution, and then move the sucrose solution to the proboscis, and they get a sugar reward. So over time, they learn to associate when I sense the UBO, I'm going to get a sugar reward and stick out their tongue. And so that was fun to do, and it took them about three lessons essentially to learn how to do that. But they all, most of the bees learned well, and they could associate this UBO with the sugar reward. And so what we did then was we got to the point just like Pavlov's dog. So Pavlov, I think it was ring the bell, yeah, and then gave the food. And he noticed that over time he could ring the bell and the dogs would salivate, expecting the food just from ringing the bell. So we could do the same thing here. We could then, after this training period, we could just touch the antenna of the bee with the UBOs, and they stick out their tongue. No sugar reward required. And then the next day we had a quiz, and we looked at 24-hour memory. And what we saw was that colonies that came from individual bees that came from these high UBO colonies had significantly better memory of those UBOs. So when we just touched the UBO to their antenna 24 hours later, they would still stick out their tongue. They remembered the UBOs, and they did a better job at remembering than the low-scoring colonies. So that was a really exciting. That experiment actually has several other parts to it, but I thought that was a really neat one I wanted to share with you. Okay, so that's the concrete data. So now on to the preliminary data, the stuff where analysis is underway. I think we're still out on the VSH. Is there a correlation between UBO and VSH with respect to selection based on mite non-reproduction? I think there is still debate in the scientific community of whether VSH and suppression of mite reproduction are the same thing or not. I would love to hear your opinions on that. I have my own, but I think we're not sure yet of that correlation. We have a lot of data coming in, so we'll see what we find. I also have a lot of virus samples right now in the lab being analyzed by my friend and colleague Ismail Miri. So we look forward to getting those results back, and then I can take away that preliminary note on those virus data, and we can see if that effect that we saw with the small sample size really stands. So I'm excited to see those. We have another group also looking at some virus data with high and low UBOs. So we'll see if those two data sets match, and should have another update for you soon in terms of the virus correlation with UBO. I've seen some preliminary data from collaborators regarding cell recapping. Positive correlation with recapping and UBO response. And then I just did, a quick preliminary study with a Foster lab up in Canada, and we did see significant differences in expression, over and under expression of certain odorant binding proteins in high and low UBO colonies. So we do have plans to follow up on that next year. I'm really excited to see what comes out of that study. And then there's still things we don't know yet. I actually got a collaborator just sent me some data. I saw like 5 minutes before we started the live stream, so I haven't looked at it yet. But soon we should know maybe something about nosema, hopefully some other diseases. Do high UBO colonies have lower nosema, lower chalk brood? That's yet to be determined. And so I look forward to, continuously expanding what we know about UBO, but this is kind of the summary thus far. So I wanted to take a minute and talk about, why I think it's important, the significance of UBO. In terms of breeding, again, going back to the hygienic daughter queens, I think one thing it allows us to do is more easily verify those hygienic daughters. So what we can do is really make sure that when we're selling hygienic bees, hygienic queens, or buying hygienic queens, that's really what we're getting. And that's, I think, something that all of us want. I also think it's important for improving our ability to select for hygiene locally. So, it's great to have these breeders that you can buy hygienic queens from, but if they're not in your area, for example, if you're buying hygienic queens from the Southeast and you live in the Northeast, you may lose some of your winter tolerance, for example, if you have to bring in Southern bees to breed hygienic behavior or Varroa resistance into your local population. So one thing I love about UBO is I think it's going to help make it easier to select locally, maintain those locally important traits, but select for hygienic behavior within bees that have those traits already. I also think it improves hygienic resolution. So what I mean by that, when we look at something like freeze-kill brood, we see typically we use 95% as the threshold. So there's not a lot of room for you to tell within that 95 to 100% to distinguish colonies. And so just having a broader range of Varroa resistant colonies, 60 to 100%, I think gives us a little bit resolution within our hygienic bees of determining how effective they are, how we can use them differently for different purposes. So for example, and I don't have data to back this up or anything, but maybe the ones that are 60% to start, they can handle their Varroa, they just cross that threshold of 60%, but maybe when they're open mated, you're less likely to maintain those genes. If you're natural mating, maybe you want to choose the ones that are really scoring 100%. You want to graft eggs from those 100%ers, and then if they mate with some drones that aren't as hygienic, you don't lose all of your Varroa resistance. Maybe somewhere in the middle is ideal for insemination. Again, this is just an example, but I think it's nice to have that range. I also want to point out that most of your colonies are not going to be in this range right now. So this is a new tool, not even available yet, and so it hasn't been used for selection. And so really, when I test colonies, most colonies fall in this really low bracket. And so, I don't want beekeepers to be excited about this and test their colonies and get really disappointed when they get a 5 or a 10%, because I think that's what we should expect right now when we haven't been selecting for it. If your colony was gonna, if most of the colonies were scoring 60 to 100%, we probably wouldn't need to be treating our colonies, and most colonies need some kind of treatment or some kind of control. And so, I just want to point out that most of the colonies right now fall here, and I think if we can start using UBO as a breeding tool, we can slide that average up and start really improving our Varroa resistance. In terms of management, I've really tried to focus on making the UBO assay accessible, something that's beekeeper friendly, and we're still working on all the specifics of how we're going to apply it to the test area. That's why it's not available yet. But our goal is to make it something that's really easy and quick to use. And I think it's going to be useful for comparing queen breeders. Or even if you only have 5 or 10 colonies in your backyard, I think the UBO can still be informative, because you can say, okay, if I lose a queen, which colony should I grab eggs from? And I'm not saying that you should always base that on UBO, because I think it's really important not to ignore other traits. There's lots of really important traits that we need to keep in mind and select for. But if you want to raise the Varroa resistance in your apiary, and you know which of your colonies is most resistant in terms of hygienic behavior, you can build up your Varroa resistance by grafting from that individual or requeening based on that colony's eggs. And again, I think maybe more important on the commercial beekeeping scale, but I think we have potential to limit mite drift if we IDR resistant colonies, isolate them from our susceptible colonies, limit that mite drift. I think that has a big potential to reduce the need for treatments across the board. And also it just streamlines the treatment process. If you have an apiary that shouldn't really need treatment and one that does, you can just take your treatments where they're needed and leave the rest alone. And I haven't talked much about native bees. My focus has traditionally been honeybees, but I am really interested in native pollinators. And I think we have potential here to decrease the spread of pathogens and parasites to other pollinators. So we know that honeybees and native pollinators, they share resources, they share flowers. There was a study from 2020 that showed there were bee pathogens in 42% of bee species and 70% of flower species. I mean, just that's way more than I would have expected. And so I think we have the potential, and as beekeepers, also really the responsibility to keep our bees healthy, and in controlling our honeybees and reducing disease and problems in our honeybees. I think we have potential to benefit native bee health and native pollinators. And I think that's really important because we don't always know what's going on in native bee populations. We're not managing them the same way we manage our honeybees. If something's wrong in a honeybee colony, we all find out really quickly, in the large scale. But it takes researchers looking really closely at these native pollinators to be able to tell when there's a problem. So, I think this is a really important point, that we have potential and we have a responsibility to keep our bees healthy, to help native bees. So where are we going from here? So there's tons of trials underway, lots more data to come, and I'm really excited about that because I've been building this project for 11, 12 years now since I started my PhD, and so it's really nice to start getting other people to test this and seeing their data and what they find. I am continuing to look at virus dynamics in hygienic colonies. I'm excited about this odor and binding protein expression. Um, but really, my main focus right now is just getting this assay into the hands of beekeepers. Um, I am a researcher, not a business person traditionally. So this entrepreneurial side is all new to me, and I'm working really hard. I'm learning a lot, but my goal is to get this on the shelves and make it available to you so that you can try it and see what you think in your own colonies. I mentioned before we have a lot of work to do still with the applicator. We have a nice prototype. It's still working out some kinks, but I think we're getting closer. Um, and we're looking at things like environmental effects on the assay. So, there's a study that shows that exposure to smoke, for example, from the smoker can dull the olfactory ability of honeybees for about 20 minutes. So that's fine if you're just going into your colonies and blowing some smoke on them to calm them down. But if you're running a test that's related to their ability to sense something by smell, then maybe that has an impact. So we did some tests on that this year. We're going to continue into next year. And I'll let you know what we find. We're also looking, if you have a screen bottom board versus solid bottom board, does that airflow difference have an impact? And one thing we really want to investigate is nectar flow. So traditionally, I've seen much lower hygienic scores in the late summer, early fall than I have in the spring to midsummer. And so I thought this was maybe a seasonal effect. But this past year, I was actually feeding my bees while I did the UBOs in late August, and the scores were much higher. So they were kind of on par with what we'd seen earlier in the season. So I thought that was really interesting. So next year we want to do some tests to see, does the flow of nectar affect how they perform on UBO and how much hygiene they're doing in the colony. All right, so lots and lots of people involved in this work. First, I want to thank Phoebe Snyder. Phoebe co-founded Octoro with me. She's the businesswoman and great at it. And this UBO would not be coming to you without Phoebe. She's been critical for this work. Olaf Ruppel and Marla Spivak both have been critical to this work. They served on my PhD committee. UNCG, my alma mater, they can't get rid of me. I've been there for years now and love it. They've been great to me, and this research has been made possible by them. We've had funding from USDA, NSF, the I-Corps program. If you have an invention and scientific discovery and want to turn it into something that people can use, the I-Corps program is fantastic. Of course, Project APISM, we've talked about many times. Both Project APISM and NC Biotech really bridged that gap when we had these really exciting findings, but didn't have any, huge government funding to get us, 3 years of research. Pam and NC Biotech stepped in and made it possible. We got a matching grant also from One North Carolina Small Business Program. BARD has funded us, and actually we've been really lucky to have support from some of our local bee clubs and bee suppliers. So H&S Bee Supply, Apin Bees, and Surrey County Beekeepers Association have all supported our work. And of course, Umberto, thanks so much for having me on Inside the Hive TV.
Oh my goodness, that's my pleasure. I feel that I need to thank you to share all this work. We are working. We
Not at
start.
all. It's no good if I do all this work and don't share it. So
No,
no, I
yeah.
really
Thank
appreciate
you. I
the
think
chance.
everybody at home appreciate your work. How many years? I was there with you. We
Ugh.
overlap the last year. I remember passing through you and look at you in that mass back, and I was thinking, poor girl, poor girl.
Rough times with that mess
Rough
back.
times. Yes, I
Yeah. No,
remember.
yeah, I started the PhD in 2011. So
Yeah.
yeah,
Yeah.
11 years now
No. Well,
plus.
let's stop counting. Yeah.
Yeah. Yeah, I'm feeling old now.
Yeah.
Okay,
Kara,
let me
I
come
want
back so
to.
I can see your face here. There we go.
Here you go. So, before I go to the people at home and get some questions, I want you to, because what I do for a living is this, to help companies to bring new products to the market,
Hmm.
consulting for commercial beekeepers and big companies, looking at different portfolios and trying to find technology that we can translate and bring new tools to the beekeeper. That's what I do. I couldn't work with you at the time. I was engaged in many other things. But now I have a lot of business questions.
Uh-oh.
I want to ask you a couple of things, like who your who is your target con-
Who's
cu-
my target?
customer? Yes, and
Yeah.
also after that, can you tell me a little bit of your market research, because this is so difficult in the beekeeping industry. How to have the right questions to the right people to try to bring the right value of your product. And
Yeah,
if you can feed me a little bit of how you did it, because it's not easy. It's not an easy thing.
it's not, and it's been a learning process for sure. I think the people who will adopt this technology fastest and maybe be most successful with it are breeders. The people that are already interested in selecting for Varroa resistance and have already been doing it. Um, Part of that is because it's already their focus, and part of that is because when they take UBO and test their colonies, they're going to see some interesting things happening, and be able to work from there. But like I said, I think hobbyists also, this has a place with hobbyists. So I think backyard beekeepers can, if they're interested in selecting for Varroa resistance, they can use this. I have even a couple of collaborators in Australia now. Australia first saw Varroa this year.
Yeah, yeah, yeah,
Um,
yeah.
I think they're really worried about Varroa and what's going to happen if Varroa takes hold. But it's very difficult to select for Varroa resistance when you don't have any Varroa, in your own colonies yet, to be measuring. And so
Yeah.
it's kind of exciting. I mean, that's not a big target or anything, Australia, but I think it's really exciting to be able to help in that way too. Um, in terms of the market research, so this is where I guess it comes back to NSF and ICOR. That program has been uh, just really critical, and I'm sure there are probably a ton of you on this YouTube or watching it later, not live, that I've talked to on the phone, or Phoebe Snyder has talked to on the phone. And thank you. Um, you know, Part of that program, we had to, in the first round, reach out to 100 beekeepers essentially, and just start asking them questions. So really, what we were trying to determine is, what problems are they facing? What are their problems that they want solved? We try not to tell them too much about our product. What is UBO? We just are trying to learn, what are the major problems in their industry, and then we decide on our own, is what we're working with here, the UBO, is it solving the problem that they have? And so that's really how we started the market research. And I have learned so much just from talking. I mean, it's incredible, just the opportunity to do that and to talk to so many beekeepers and learn so much from them about, what they do and how their operation works. It's been an amazing journey.
Okay, so it was business 101. You have to follow a certain protocol for your institution that you got money from, right? So it's basically 100 people and you interview, but you didn't have the experience, right? So you have consultants helping you, or because you need to do this in a very specific way and the right questions, and to avoid biases from the people that you ask. And it's very methodic. It's very complicated.
Sure. Yeah, so it was a whole program that we went through, the ICOR, and they really trained us well with, how to ask the right questions, and how to think about, um, posing questions to get the information that would be helpful to us. Um, we've also worked with a group called VentureWell that has actually provided market research data for us, and that's kind of helping us write a proposal to continue funding the work. This it's I never knew how hard it is to have a business. I don't know
Yeah.
how anybody does this type of thing without being just really rich to begin with, or taking on a whole lot of debt if you can't get
Yep.
these grants. Because if we didn't have this funding from NSF to support development of this, it never would have happened.
Yeah, the system is brutal. Yeah, the system is brutal. If you're small and you have a good idea, its system is built to basically take it from you. I hate to say that, but you got this done. And that's why I'm so proud of you, because I remember you starting from zero, and now you pass through, and so there is ways to do it, and it's good to see
Well, we're
that
not
there's.
there yet. We're
Yeah,
not
yeah,
there yet, but
I
we've
know.
come a long way. Yeah.
Yeah, and I want to put you in a spot, because if I don't put you in a spot, it's not me. I want to talk about price. Can we talk about price?
Yeah, and actually, can I show
I want to know how you're pricing this.
yeah, I will tell you. And we also, I forgot, I have one more slide. Can I put one more
Okay.
slide?
Yes.
Okay, can you see it there?
Yes. Question is scammy.
Scan me. Okay, this just
Scan me.
takes you to our website. So we do not have a final price. We're still sourcing materials. But we do estimate that the UBO assay will be less than $20 per test. So
20
if you
$20 per test.
less than $20 per test, yes. And so the reason that reminded me of this slide is we have we're
Retail.
sorry.
Uh, for small quantities, or the price for big quantities have discount. How
Yeah,
this
so
is
we're still over a year out from launching, as far as we know. That our estimated launch is spring 2024. So we're still working out those details, but yes, that's our expectation, that you'll get discounts for larger quantity purchases. Um, we're taking pre-orders now, so that's completely non-binding. Essentially what we're trying to do is figure out where people are coming from with their interest, how many tests people would like to have. It's going to kind of help us guide how much of the product to make. Also, we're planning launch for spring 2024 in the US, and we want to move abroad quickly after that. So if you're listening from outside the US and you're interested, and you think you would want some, you can place a pre-order and just tell us where you are. Let us know kind of where to focus. Do we go to Europe next? Do we go to Australia? Do we go to Canada next? We're trying to kind of figure out. We can't be everywhere all at once, so we're trying to figure out where to prioritize, and just get a sense of what people want, when they want it, and yeah. So go check out our website, opterabees.com. And of course, if you have any questions, there's an email there. You can get in contact with us. So I'll go out of this now. I just wanted to, it tells on the website. It shows us that. Sorry, it shows the visitor of the website that our predicted price is below $20, and it'll ultimately come down to what is the cost of this applicator that we're designing. It looks like this prototype may work. If it doesn't, we're going to have to tweak it. If you have to have a mold built to design a new part, all that's going to add to the cost. But hopefully that's not the case, and we can get this out there soon.
interesting. Interesting. Um, Almost 20. Hmm. Uh, Interesting. We can need to talk. So, here we go. We don't need to talk. I'll post it right here. That's exactly what I was thinking.
How would you justify this test for $20? Yeah, so I definitely wouldn't recommend testing 2,000 hives. If you have 2,000 hives, I think you can say for sure 1,000, I don't know, 600, maybe 1,800 that you would never use as a breeder, right? Hopefully you know that some of your colonies don't look good for one reason. Some of your colonies have poor brood patterns. Some of your colonies are filled with mites. Some of your colonies don't bring in enough honey. So my suggestion would be to narrow down who are your potential breeders. Who do you think you may want to breed from? And then from that group, you pick your best colonies based on UBO. So that would be my recommendation.
So
I don't expect any large scale commercial beekeeper to be testing all of their colonies.
Yeah, that's what I was asking. What's the target? So it's not for a commercial beekeeping operation with 60, 100,000 hives. Test all of them and try. So the value. Yeah, I see where you're going. Yeah.
Mm-hmm. Well, it depends. I mean, if they want to, if they don't want to buy queens, if they want to, do their own selection, then yeah, same thing. Take their best, their top potential colonies, and from those, figure out which are the most hygienic, and you can start increasing. It doesn't have to be all at once. I think this is something that can be built over time, and it's going to have to be built over time. You're going to have to increase your Varroa resistance. It's not a magic bullet. It's another hopefully really useful tool in the toolbox, but it's another tool, and we can't ignore our mite counts or other things just because we have this assay. So I think that's a really important point to make.
Interesting. So let's start to get more questions here. If you guys have questions, that's the time. I'm not sure I understood, but you can help me here, Kaira.
So we are still going to paint for this UBO testing. Maybe pay for this UBO testing?
Yeah, that's what I was thinking. But
for this UBO.
Stuart, I think if you can ask it again, I will put it back.
Yeah, I mean, so one of my hopes for the breeders is that, and I think this will benefit everybody, if breeders are better able to test their daughter queens, right, for hygiene and for Varroa resistance, then they can maybe say, okay, this is a verified hygienic daughter queen.
Kaira, I think your microphone is in your
sorry.
Kind of is making a little noise here. I don't know if.
Let's see. Is that better?
Say it again.
Can you hear me?
Yes.
Okay. Now I lost my train of thought.
Sorry.
So no, that's okay. If you can't hear me, you can't hear me. Yeah.
Yeah.
So I think that if a breeder has certain colonies that certain daughter queens that they say, this is a daughter of a very hygienic mother, but this daughter hasn't been tested. That's one price queen. Then they can say, okay, I have this group of medium hygiene daughters, right? They weren't quite 60, but they're better than your unselected Italian queen. Then they can say, okay, now I have this queen tested 85% on UBO, and this is different prices they can sell then for their queens, and people hopefully would be willing then to pay more for the hygienic queen. And if they want to verify it, they can test it themselves, but hopefully trust that it's already tested by the breeder.
Got it.
I don't know if that answers this question. I'm not quite clear on this question, but but I think the cost will trickle down if you're buying that more hygienic queen. But you're also getting a better bee and a better colony that needs less treatment, that's healthier, that's maybe producing more because it's healthier. So I think the benefit trickles down as well.
Yeah, the calculation should include less treatment, more bees, perhaps more honey production. I don't know if
Well,
you
and I
measure
think
any of this.
I think the biggest thing is better survival too.
Yeah,
A nuke is not cheap. A
yeah,
package is not cheap. So if you're not losing colonies as much, again we saw 41% higher overwintering survival with these high UBO colonies. So if you're not replacing as many colonies each year, that's huge. That's a huge savings.
yeah. So Bruce is saying that he's looking to use UBO to help narrow the field for selection of breeder.
Great. Yeah, and again, I'm really interested to see with AI, what turns out to be best within that range of 60 to 100. I think always with any trait, you can over select for it. So if you have 100% mother and 100% drones going in, at some point maybe you get an over selection for hygienic behavior, an over
Yeah,
selection
yeah,
for resistance. So I think it'll be really nice to have this scale that we can work with. And of course, it's a diluted mixture of these compounds. So we can always, play with dilutions in the future as well. I think
yeah.
that's
I
something
didn't
to come.
I didn't think about that, but yeah. Cody, is the Cody that I'm thinking? Maybe. If you don't have to pay as much for my treatments and your bees stay alive, I think it will pay for itself. So
Yeah,
potential customers giving their opinion. This is very important for your also for your market research.
yeah,
Okay.
yeah. We'll keep it as low as we can.
Yeah, you can test, you have the investment to when you buy the hygienic queen, maybe we can test
Mhm.
it just to make sure and then you get your money back or yeah, there is a lot of ways that the money can circulate in this system, yeah.
Yeah, and I think it depends on what breeders are willing to do in terms of time frame. So,
Yeah.
if breeders are wanting to pump out queens in February and sell them in March, or graft in March and sell them in April, May, um, you can't sell them right away as tested. I showed that with the heritability study. You really have to wait 7 weeks from when she emerges to get accurate data,
Yeah.
it seems. And the longer you wait, the more accurate it is. But I think 7 weeks is the pattern is very clear. The results are reliable.
Yeah.
And so if you want as a breeder to test your daughters, you're going to have to plan for that and wait a little bit.
Yep. True. See?
The game
But
changer for smaller queen breeders and self-sustaining small operations. Yeah, I hope so.
potential customers saying what they think. Oh,
Yeah,
interesting
fellow
question for you.
beekeepers. I prefer thinking like fellow beekeepers.
Yeah, fellow beekeepers.
In in my job, I'm now an entrepreneur, but in my heart, I'm a researcher and a beekeeper.
Yeah, I'm doing too much of that. I think I need to retire and go back to bees, and that's it.
Is there a
Is there a
correlation
correlation?
between UBO uncapped cells and actual removal of larvae? Yeah, it's a great question. So we actually don't tend to see very much removal. So that's one thing I really like about the assay. Um, you're essentially spraying these compounds on the wax. So the worker comes along, she uncaps the cell, and then typically it's a different bee, a different set of bees that come along and do the removal or the recapping. And with UBO, once the uncapping is done, they look inside and typically they see no problem, right? Unless you have mites by chance in those cells, they don't see a problem. And so we don't typically get a lot of removal with the UBO assay, and we see recapping. So that's why actually we stop the test at 2 hours, because if you go beyond 2 hours, sometimes you start to see that you get inaccurate results because they're already starting to recap the cells. They think it's an error, which essentially it is. It's a false signal, and so they say there's no problem here, and they recap the cell. Yeah, if there's a mite in the uncapped cell, then I would think that she's much more likely to be removed. So I think the bottleneck in the hygienic behavior process is the ability to detect through a capped cell the mite's presence. Because once the cell's open, I think it's much easier to the antenna of the bee can actually just physically touch the brood. It can sense around in the cell, and so I think if they're uncapping the brood in that way, then if there's a mite present, it's going to be removed. So I've thought about the UBO assay as a potential treatment for bees. So if you can kind of trigger on a larger scale uncapping and have them kind of, in a sense, examine more freely all of the cells and remove problem cells and recap the others. So I think that is a potential application. But I think you come into the problem of, we see that hygienic behavior is performed by specialists. It's not like in a hygienic hive, you have hundreds and hundreds and hundreds of bees performing hygiene. Typically, at least in a smaller area, it's like one or two bees doing most of that work. And so I think if you try to use it as a treatment and uncap a bunch of cells, you can overwhelm just the physical ability of the hygienic workers, those that performing that subtask, to actually be able to complete the task. And I always wonder about, uncapping, if there's some potential exposure to viruses of the brood or of the pupae if it's uncapped. So if you're triggering uncapping of all your brood, maybe are you also exposing them to potential pathogens? I don't know. I don't know if you know any research on that, Humberto.
No, I can't remember anything right now. If I can, I will make a post on YouTube so I can share with everybody. Okay, I can see that with the foundress, but what happens to the developing nymph if the cells is recapped?
Yeah, so I mean, they don't typically pull out the foundress, right? Don't they pull out
Yeah,
generally the whole brood? So I think it would essentially disrupt the whole process
the
of.
whole process. Yeah,
I mean, from my understanding, even just the process of uncapping, even with recapping and not removal, somehow interrupts the process and makes the Varroa less likely to reproduce successfully. I'm not sure the mechanism behind that's understood, but
yeah. All right, market research still. You need to know those things. I will keep it coming. 1, 2. Yep. You're gonna hear all of these things, and it's important to hear all these things.
yeah, it's fair. Yeah. Yeah, I don't think the selection process starts with UBO.
That's a good point, yeah. Okay. Mark Miller.
Spray with mama mite smells would target the VS. Yeah, so I think it's still a question of if suppression of mite reproduction is really the same as VSH. So, okay, so I think that UBO is is correlating with Varroa-specific hygiene, because we see that bees that perform well on UBO assay have fewer Varroa. But I don't think that the UBO compounds themselves are specific to Varroa. Like you said, we're not using mama mite smells, but I actually, we see some potential advantages of that. So we see that that some of the viruses that were lower in the high UBO colonies are viruses that are not associated with Varroa mites at all. They're not vectored by Varroa. So I think that these compounds are general signals sent out by honeybee pupae to say, hey, something's not right. Sacrifice me, or whether it's intentional, if you want to say intentional with honeybees, whether it's an intentional signal or whether it's a cue that just happens when you're an unhealthy brood. I think that signal goes out. And one of the best pieces of evidence to support that is that one of the compounds that we've identified in triggering hygienic behavior in honeybees also has been found to trigger a similar behavior called unpacking in ants. And so I think evolutionarily, this is a longer term, something that's been used by social insects for a long time to essentially trigger this kind of hygienic removal or uncapping behavior or unpacking behavior in ant colonies. So I think that to be Varroa specific or to have an effect on Varroa populations, it doesn't necessarily have to be specific to the smell of the mites. As long as the mites are doing damage to the bees, if we're selecting for the bees' ability to detect that damage, we can get the end result that we want is less Varroa.
So my question then for you, Kaira, if I remember correctly, I remember you got many different compounds. There are other products maybe coming. There is any other thing coming from the. I remember there is a selection of compounds that you isolated. What is something
Yeah,
be
so
doing with that? Something coming?
there are potential. There are other compounds that we're exploring that we've had synthesized in the lab. So potentially a second generation. Right now I want to get this product out and to have people be able to use it and see for themselves. But yeah, there's definitely some second generation plans in the works. But we try first to focus on getting
Yeah,
this
and
one out. Yeah.
maybe I'm open my mouth for things that I'm
No,
not
not at
supposed
all.
to.
There's no secrets.
Okay, good, good. Yes, because I was thinking just trying to protect the business. You need to be thinking about second, third generation of new products. We need to keep this ball rolling.
Yeah, I mean, I hope my goal is to put out a good first product, but I'm always wanting to improve.
Yeah.
The purchaser can score their own colonies and get rapid scores without. Yeah, so the idea is this is hopefully something that any beekeeper could have access to. I think that's the question, that it's not something you have to send off to be tested, or that somebody has to come. But yeah, you can examine your own colonies quickly. Phoebe and I can go through our apiary and I think in an 8-hour day we can pretty easily get through 50, 60 colonies. If somebody's sitting there running the frames and somebody's sitting at a table running the assays, you can really get through a good amount pretty quickly. Is this like testing with dry ice? So I think maybe this is in reference to the freeze kill brood assay. So we do see correlations between freeze kill brood assay and UBO assay in most cases. They're not super strong correlations. So, I think it's definitely testing for something else. It's testing for response to these UBOs as opposed to response. We know, for example, dead brood is producing different chemicals, like releasing oleic acid, for example. So I think that you're selecting for something different when you're selecting using freeze kill brood assay than you are with UBO. In my studies, I've found that when you compare the same colonies, how they did on the freeze kill brood test and the UBO test, the ones that score high on freeze kill brood have fewer mites than the ones that score low on freeze kill brood. But the difference is a little bit clearer when you use the UBO assay. So you can better tell or predict which colonies are going to have the low Varroa population in August and which will have the high.
Adam Collins in.
We worked with UBO testing this summer. Very impressive. Are any of your current tests looking at recapping or brood removal as part of the test? Yeah, so I did see recently from a collaborator a significant correlation between UBO and recapping. But I haven't looked at, do you mean brood removal like a mite infested brood, or I'm not sure what exactly that means.
Yeah.
But yes, we're trying to cover everything. I want to know how it correlates to all these different behaviors. There's a lot of questions there, and I think recapping is one we now have a small data set on, but I would like to look some more at that, and hopefully all those will be published soon.
Yeah.
Lots of data coming in, so there's lots of work to do, but it's tough to balance my researcher side who says I have to publish this, and my business side who says I need to get this out, or even my beekeeper side that says I have to get this out to people. So Umberto, that's why I really appreciate things like this, because it's a way for me to kind of share the information without, it's not published, it's not peer reviewed, a lot of what I share here. And I think that peer review process is very important, and I plan to go through it and publish this. But I also love that I can share kind of the broad idea of what the findings are, because I think that informs the beekeepers and the breeders.
Yeah. All right. So, people from Hungary want your product. See, just to keep on your notes.
All right, noted.
And Hungary have lots of bees. And I'm sorry, guys, you lost the bead for Apimondia. I'm sorry. More market research and information.
Mm-hmm. North Dakota does not have any breeders. Yeah, so I would hope that this would facilitate more local breeders in North Dakota. That would be my hope, is that, having this out there are more people that are willing to take it up. They don't maybe have to spend 6-8 hours in a hive looking for mite babies, but they can find Varroa resistance more easily. But yeah, we'll do our best to keep the price down, but we have to have lights and
Yeah, it's when become a business, you need to make something that is sustainable. Otherwise, it's not a business. Everything
right.
dies.
Yeah.
Yeah, tell me about the applicator.
Yeah, I don't know how much I can tell you about the applicator, because we don't know yet what it's going to look like.
Okay.
But yeah, the idea is that it's a quick, easy process that you don't have to do any measuring yourself, like we always do in the research apiary. But it's just quick, easy application, and usually the solvent that the compounds are diluted in evaporates very quickly, maybe 20-25 seconds, and then once it's dry, you put the frame back into the colony and you're ready to start testing. Does the age of the capping... Oh,
yeah, sorry.
That's okay. Does the age of the capping matter? So that's a great question. What was before to remove the capping? Yes, so it does not harm the larvae. So I did initially some tests where we looked at like pulling the larvae out that the cap was treated, and we didn't find any difference in the compounds that were on those larvae. So it doesn't seem to be going through the cap at all. I think if it was, then you would see the removal behavior instead of the recapping. The age of the larvae underneath does not matter. So as long as it's capped, and the only caveat I'll say is, if it's essentially a moving pupae, so starting to turn black and getting ready to emerge, what I have seen is that I don't understand quite why, but the UBO assay can actually kind of trigger an early exit for those individuals. So if they're about to emerge and you spray it with UBO, it kind of, they seem to get agitated or something and they come out. But as long as it's,
Did you
recently
follow?
capped larvae all the way up to purple eye, it's no problem.
Do you know where they go? They jump out of the hive.
No, they just emerge early,
Hmm.
normal. They seem completely fine. It just
They
stimulates
just,
for some
yeah.
reason. Yeah. I missed the last one, or it was the
Oh,
same.
that was the last one. Sorry.
Okay, yeah, that was it.
Yeah, I think we got it. Okay, people already doing some investment. Congratulations, Kara.
Yeah, so we're not taking money yet, so don't think that if you make a pre-order you have to pay anything. The idea is just to get an idea, and I think the benefit on the part of people who make the pre-order is when we're almost ready to launch the product, hopefully spring 2024, but whenever that ends up being, um, we're going to call those people first that made a pre-order and confirm, do you want to complete your order? If so, that order gets filled, and once we've gone through all those, what we have left, it becomes available.
Information. Good.
Yeah, so the idea is to have an applicator that's reused. Exactly. Yeah. Yeah, so it should, if this prototype we're working with works out, then it should be the same applicator each time, and then you just pop on a test file. Is there going to be a shelf life? Yeah, that's a good question. I keep mine in the fridge, but the compounds are stable. So you just want to avoid any evaporation, but they'll come in a sealed vial. So yeah, I think the shelf life is not something we have to worry about. It's a matter of years. Yeah, reusable applicator is definitely the plan.
All right. I think we reach our end. If everybody doesn't have any other question, I think whew, that was a good one.
Thanks.
Kara,
I really appreciate all the questions. So
yes.
I love hearing everybody's questions and the thoughts. Also back from the wire study. It's really great to have the input and the thoughts. I love
Oh,
the
gentleman from
community, the beekeeping community is just
just
amazing.
one more that I got my curiosity too. Did you see any of that in drone brood?
We haven't tested it on drone brood.
Oh,
Yeah.
hmm.
No, I don't think it's going to be any different because the activity is performed by the worker in response to the compounds that are present. But no, we didn't try it on drone brood.
Yeah, I'm curious now too. All right, Carrot. I think Wow, we have a lot of food for thought here, and I want to thank you one more time for your time, for all the work you do, for people are very excited about this. I didn't expect the first time I put the video out there and talk about your work that we're gonna be that amount of response and success. Just this is just a reminder of what people are expecting out there. People are expecting products that can be sustainable, help beekeepers in a way that's not more you know heavy chemicals or things like that. So we need to listen to the beekeepers. That's what I always um, trying to promote and tell companies out there: listen to the beekeepers. Don't try to change behavior and no, we need to do this. No, listen to the beekeepers. That
The
is,
beekeepers know best. They know
they
their bees.
know. Yeah,
They know
they
what they
know.
want. They know what they need. Yeah,
Yeah, and
I
sometimes they
agree.
just don't follow by, and then you see the company. Yeah, that
Yeah.
happened
So talk to me. I
most.
want to hear from you.
Yes. All
And thanks
right.
so much for the opportunity again. It's really great
It's
to be
my
back, and
and I
I
saw there
love
is a
what you're
lot
doing.
a lot of follow-ups. You're gonna come back. I gonna there is a lot of those experiments that you put the slides there that I want you back talking about those.
Oh, there's a lot of data to come.
I
Yeah, a lot.
know, I know. I'm looking
I'm
looking
excited.
forward to that. Looking
The,
forward to.
the scientist's favorite thing is incoming data, right? You work so hard
Yeah,
to do the experiment. Now the
but I'm
data
gonna need
coming
to
in
tell
is
you
the fun.
something. It's gonna reach a time that you're gonna need to decide. You're gonna be a researcher or a business person. I don't think you're gonna have a choice. So
Oh, why not? Best of both worlds. Yeah.
I hope you can find your way.
Yeah. So far, so good.
Good.
We'll see what happens, but
Yeah.
so far I'm enjoying. I love both. So,
Good.
but no matter what, the beekeeping is the umbrella that it all falls under.
Yes.
So,
All right, guys. I just want to thank you, everybody at home, for your time here. It's always a pleasure to have you guys here. And I will see you guys in the next video inside the Hive.tv, the show about bees. See you guys next week.